this is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic Kruskal's algorithm. So what is meant by Kruskal's algorithm? Kruskal's algorithm, it is used to find a minimum cost of a spanning tree. A spanning tree is nothing but a connected graph using all the vertices in which there are no loops. In other words, we can say that there is a path from any vertex to any other vertex but with no loops. So we have to see what is minimum spanning tree also. So minimum spanning tree is a spanning tree that has the smallest total edge weight. The Kruskal algorithm is an algorithm that takes the graph as input and finds the edges from the graph, which forms a tree that includes every vertex of a graph. Working of Kruskal's algorithm, we'll see that. So before that, we'll get into the topic Kruskal's algorithm. Kruskal's algorithm is an algorithm for computing the minimum spanning tree, that is MST of a weighted graph. A minimum spanning tree is a spanning tree of a connected undirected graph which connects all the vertices together with the minimum total weightage for its edges, and it always have v minus 1 edges, that is always the edges will be the vertices minus 1, the number will be the number of edges for a Kruskal algorithm. So we'll see the working of a Kruskal algorithm. So the working of a Kruskal algorithm, we have three very important steps. So find short, or first you have to sort the edges in the ascending order of their edges weight. And in the second step, you have to consider the edge which is having the lowest weight and add it in the spanning tree. If adding any edge in a spanning tree creates a cycle, then reject the edge. Keep adding the edges until we reach the end vertex. So let's understand through an example. So consider the below graph. Now we have to calculate the minimum spanning tree of the below graph. To find the minimum cost spanning tree, the first step is to remove all the loops and the parallel edges from the graph, since here there is no parallel edge also and there is no loop. Now we have to find the vertices and the weight of the edges. So here in this example, we have B to C 1, okay, and B to A it is 2, B to D it is 5, A to C the weight is 2, D to C the weight is 3. So if we take, we all know what is the vertices. So vertices are A, B, C and D, and the weight of the edge is also denoted. So edge is nothing but the line collecting two vertices is called as an edge, and the weight of the edge is called the cost of the edge. So how to find minimal spanning tree? By using Kruskal's algorithm. We will always start from the smallest weight edge and keep selecting edges that does not form any loop or circle with the previously selected edges. This is the most important thing to be remembered. Remember, if there is any loop, we have to remove that edge. So steps to find minimum spanning tree by using Kruskal's algorithm. So first create the edge table. An edge table will have name of all the edges along with their weights in the ascending order. So here in the given graph we have 5 edges. So our edge table will have 5 columns. Okay. Next, create the edge table. So our edge table will have 5 columns. So now this is the time to find minimal spanning tree by using Kruskal's algorithm. So edges we know, so namely BC, BA, BD, AC, DC, these are the edges. So as I told you before, edges are nothing but the line collecting two vertices. So if we take the weight of the edge BC, it is 1, AB it is 2, AC 2, DC 2, BD 5. So when we write in the form, the smallest weight is 1 being for the edge BC. So first draw BC. So this is the first step. Next one, Now when we consider 2 is the smallest weight. So when we take 2, we have two edges AB and AC. So if we select edge AC, then it will form a circuit. So we are going to reject the edge AC. We are going to connect only, or we are going to take only the edge AB. Since we have got the three edges, so the next thing is when we take DC, the edge weight is 2, so take that also. And if we take BD, it forms a circle, so need not 2. So now we have three edges, so we will stop here. Remember, always the edge should be V minus 1. So we have to stop here. This is the solution of the given minimum spanning tree.